So in this one, digestion of wood based material. So here we will see how the wood material which comes, so that should be cheap and that will be shredded to fine particles, and there that should be mixed with the chemicals in order to get it digested. So here in digestion, what we get is the fibrous material which is high in cellulose content, and the other non-cellulosic and the lignin content which comes in black liquor. So that we will see in the digestion of wood based material. Then the bagasse which comes from the sugar industry. So there should be some modification we require to convert that bagasse into the good quality pulp. As bagasse will contain the more the materials which have to be separated, so we have to modify the process for the separation. Also, bagasse is not easy to grade into the fine particles, so we have to go for the chemical treatment to soften the bagasse, and then we can shred into the fine particles. Then the bleaching of pulp is necessary in order to get the good color to paper, and also the bacterial content also will be reduced by use of bleaching. Then finishing option of pulp. So pulp should be of good quality, and then pulp should be ready to convert into the paper. Then the chemicals which are using for the pulp preparation, that should be removed as the environmental norms are considered. Then we have to opt the separate procedure to remove the all chemicals which are using in the paper manufacturing. So this is the first step where we have to prepare the wood pulp by the sulfate process. So the wood pulp will be shredded finely. So here are the chips, they will come here and they will shredded finely, and then they will come in continuous blender. So here the shredded particles that we are shredding over here, they will come into the reactor where the digester where we are mixing the chemicals. So here the shredded things or the shredded wood material that will come into the digester. The temperature is maintained around 140 to 150, and the down it will around 170 to 180 degrees centigrade. So here we have to maintain the heat so that the material, the fibrous material, which will not deteriorate. And also at the down, the temperature is lower down by the black liquor purge. So this will help for the cellulose content not to get deteriorated. So here the black liquor will play an important role, and it will maintain the quality of the fibers which you are getting. Then here we will get the black liquor which is high in lignin content, and we will get the cellulosic high quality solution. So that will come into the strainer, and in blower tank it will be blowed. So here the water will be separated from the cellulosic material. Then in screens it will be screened, and through the rotary mixer we can have the chemicals, and we can have the pulp for the drying. So here after the pressing of the pulp, we can have the pulp for the drying, and we can have the filtrate which will contain in chemicals, so that will go to the chemical recovery. Whereas the black liquor which are coming, that will be circulated here to maintain the temperature lower than the temperature of the digester. And then mixture tank, whatever the chemicals which are using, that is recirculated in order to digest the material. So here the chemicals which are recirculating again, so that the digestion mixture is effective. So in short, if we see, then the wood material will come, it will be shredded into the very fine particle size. Then we are adding the chemicals in digester mixture, and the temperature we are meeting, so that wood becomes softened, and also it will ooze out the lignin material and other the non-cellulosic material. Then the cellulose material that we are sending to blower tank, where it will water will be removed, and then after screening then we can dry them, we can press them, and the cellulosic material will send to pulp drying. Whereas the filtrate which is in the chemicals, we will send them to chemical recovery. Whereas the lignin which are containing, it will be named as black liquor. So it will be recirculated in order to maintain temperature. Also it will contain the chemicals, and it is heated one, so we can send them to the digester again to make the wood soft again. Then the black liquor which are coming from the earlier process, that we are sending to the chemical recovery, and before that one we have to C for the chemical content of the black liquor. So it will mainly contain the lignin and non-cellulosic material. And why we require the chemical recovery from this one? Because we can't send the chemicals directly into the environment, as the environmental norms we have to follow. So the process for chemical recovery from sulfate pearl digestion liquor. So earlier we have seen the liquor was coming which will contain the chemicals. So the chemical, they will contain the digesting mixture chemicals like the caustic soda and the other base materials which softens the wood. Also after digestion we get the lignin and the other non-cellulosic material. So that will impart black color to it, and it will be referred as the black liquor. So the 6 effect evaporator system and counter current feed. So black liquor with 15 to 18% solids which are not digested in earlier case, so they will come here. And in evaporators the water will be gone out, and the soluble material, they will settle down. Then the solid, so this become the solid material will come here and the water will be evaporated. The solid material which comes here, the 48 to 54% solid, then it is sent for the mixed tank. Then it is sent to the boiler section where the carbonaceous material from here it will be burned out. So makeup chemicals like sodium sulfate and the sulfur will send over here, and here the chemicals that will converted into the non-toxic chemicals, and the carbon will be burned out. So carbon burning, it will give the steam, and the carbon will convert into carbon dioxide by release of the heat, and water will be converted into the steam, so that we can have the 28 to 30 atmospheric steam. And the burning action takes by giving the air. The hot flue gases, we can recirculate them and we can separate them in cotton precipitator. Then the material which convert into the non-toxic we will have in non-dissolved tank. Then we will send to the washing tank and to the lime slicker, where the lime and the causticizing agent will be added to them. Then we will send them in clarifier and the carbonated water which will filter them, and then the sludge which comes, we will send in the lime clean, and the reburned lime we are sending back to the lime slicker. So here we are recovering the chemicals again, and here we are adding the sodium sulfate for the digestion of the boiler section. So here main thing happens that the water, the raw material we are passing from here, so here it will have the lignin. So lignin with the sulfate contained into the dimethyl sulfonate, so that we will see in the coming slides. Also the caustic which is coming from here with the reaction of the sodium sulfate and the other material they convert into the non-toxic material here, and they can be sent to the chemical recovery, and if we can reuse them again. So here the liquor which comes from the boiler section, that will be termed as a green liquor. So green liquor because it will have the low percentage of the harmful chemicals, and it is sent to the clarifier where the chemicals will be removed, and then waste the whatever the solid which are getting over here, that will be sent as the waste sludge. Whereas the other chemicals, they will be recirculated in order to get the more chemicals required back. Then here the chemical recovery from the neutral pulp digestion liquor. So here the black liquor which again 15 to 18% solid, which are sending to 6 effective evaporator system in counter current feed. So it will come over here, then steam will be evaporated and we will get the more solid content. Again in boiler the carbon will be burned to get the carbon dioxide, then heat release, it will give the steam of 28 to 30 atmosphere. Then it is sent to the smelt in dissolver, then it will go to the drag washer where the waste material will separate out. Then green liquor which is very low content in the chemicals, so it will clarify it. Then green liquor we can have for storage, or we can recover the sodium carbonate or sodium sulfate from it. Then we will send them to the carbonating tower where we get the sodium carbonate and sodium bicarbonate, and the makeup of sodium carbonate if required then we can add over it, or we can send them to the sulfiting tower where we can get the sodium sulfate, sodium carbonate or sodium bicarbonate. So here the green liquor where the carbon will be burned, and the in carbonating tower we can have the carbonates, and in sulfiting tower we can have the sulfate of the chemicals. So if you see these chemicals, they will be less harmful in nature and they can be recovered back. So in this one we can get the chemicals back with non-harmful products. Then major engineering problem in this one, the choice of the process. So we have the sulfate and sulfide process. So the problem in this one, the recovery of the chemicals. So we have to see the process which we can yield the good quality paper. Also the process which we can give the high strength material paper, and the chemicals which are coming out of it, they will be harmful. So we have to see the raw material which we are using. So depend upon the raw material, we can choose the process and we can manufacture process in an economical way. Then earlier we were using the soda process, but the problem with the soda process that it was weakening the fibers at a very high content. So here we have to see the soda process, how we can use to soften the fibrous material. So the control of the soda or the sodium hydroxide we are using, it should be controlled. Also the byproduct which are coming after the chemical recovery, so the sulfates and carbonates, they will have the economic value. So we have to see how we can utilize them in a very economical way. Also the pollution and the waste disposal. So here the pollution norms are critical because we are burning the coal which will generate the carbon dioxide. Also many harmful gases by reaction with the sulfur will be produced. So we have to see how we can take care of them. Also the waste disposal of the materials which are not useful and which will have the not chemical value. Then we have to see about the waste disposal. And in byproduct we have the lignin. So nowadays we can use the lignin to have the dimethyl sulfate and the sulfonate. So that we'll see in the coming slides. Then the products, paper product. Then paper is defined as matted or felted sheets of fibers, usually cellulosic, and generally formed on a fine wire screen from a water suspension. Then the types of paper products, if you see, they are the wrapping paper. If you see the bag paper, grease proof paper, they will be wrapping paper. Then tissue paper generally required for the cigarettes. Then carbon, then toilet, then towel, or to form the napkins. Then for the books we require for the coated or uncoated, then textbook papers. Then for writing we require bond weight or the linen papers. Then groundwood printing paper, it is for catalog, newsprint, then wallpapers. Then paper board for heavier, less flexible and laminated papers. The raw material which will have the two types, one is fibrous and other is non-fibrous. So in fibrous we will have the paper pulp, the groundwood, then bleach and unbleached sulfite and sulfate, and the semi-chemical pulp. So we have seen this earlier slides. Then blending is done to get the maximum yield. Then reuse pulp. The paper products are repulped and mixed with the new pulp. So here the waste paper which are repulping back, and we can use them to manufacture the paper. Attention is paid toward the collection and reuse of the waste paper. So here, as we have discussed earlier, the collection should be very high, and we have to find for the newer and the high yielding technique for the reuse of the waste paper. So that waste paper we can pulp it. So the pulp, if you are repulp paper of the waste material, we can use them as a good quality pulp and we can have the paper. Then we can use the straw, linen, cotton and rags for the fibrous material. Then asbestos and glass fibers also we can use to get the high strength fibrous material. Then as far as the non-fibrous material is considered, then the large variety is required for fillers, sizing and coating are required. So when paper we are considering it with the fibrous material, we want other material which will impart the strengthness. So generally fillers we are required to give the strength for the paper. Then sizing is required. Then coating is also required to prevent it from moisture. Then inorganic raw materials like clay, talc, titanium oxide, zinc sulfide, calcium carbonate, calcium sulfate, barium sulfate and alum is required. So we have seen earlier, most of the chemical will use to give the bright color, then some of the used to give the strength, some of will use to soften the fibers, and some of will give the strengthness to the fibers. So the chemicals are required for the paper manufacturing. Then as far as the raw materials are required, then we require the rosin, then glue to stick, then we require the casein, then waxes for the glow, then glycerol, then the dye stuff for the coloring agent. So these are the non-fibrous material that will require for the paper manufacturing. Then there are the methods of production. So it will take into the following parts. So preparation of fiber suspension. So the pulp which are getting, so that will be suspended and we can have the fiber suspension. Then formation of paper takes place via this route. We issue the fiber suspension. We will form them in a wet web. Then we have to press the wet sheet and then drying the wet sheet. So here whatever the pulp which you are getting, we will suspend into the water or other solvent. So the suspension will loosen the fibrous material. Then the wet web we have to form. So generally on the string, the mesh, the paper suspension will get, and they will form the wet web of the fibrous material over the mesh surface. Then the forming of wet web, it may have the 5 meter per minute or the 500 meter per minute, depend upon the quality of paper required. So generally the speed will be high if we require the low quality paper, and speed will be low if we require the high quality paper. So generally for the good quality paper, the 5 meter per minute is the speed for the forming of wet web, whereas it may go up to 500 for the newspaper. Then after forming the wet sheet, we have to press the wet sheet in order to loosen the water content of it. So after pressing the wet sheet, we can remove the water from the paper material and we can get the dry sheet on it. Then the almost dry wet sheet we have to dry further to get the moisture content very less. So this is the process of paper manufacturing. So the pulp stock which is coming here, then the pulp stock with some makeup water, we can have the bitter over here. So it will have the suspension of the pulp stock is done over here. Then the pulp with 99.5% water, it will come here, and then here are the pressure rolls. So the suspension which comes here on the pressure rolls, so it will form the mesh over here, and after the mesh is formed, so the speed we are controlling in order to maintain the paper quality. So if speed is low, we will get the very high quality paper because the particle size, they will be spaced very closely, whereas speed is very high, then the particle size between the fiber material, they will be high. So generally that is for newspaper printing. So here when the paper, the wet web is formed, it is pressed in order to remove the moisture content of it. Then water is removed over here. Then whatever the white water which are getting, that we send back. Then the paper which is almost dry, we will send to the dry blanket where it is dry into the continuous rollers. So here the paper which got the enough strength to withstand this one. So here it will send to the rollers where it is heated one. So steam heated drying rolls, the paper will come from it and we will get the dry sheet of the paper. So here we are generally using the calendar roll type of the rollers. So the paper which is dried one, they will be rolled out and we get the finished paper. And the rolls of finished paper, we can send them for the manufacturing of different processes. So here if you see the moisture content of the operation, then initially it will have around 90% of water. Then wet forming, it will go up to the 80 to 82%. In pressing, it will have the moisture content around 60 to 65, whereas drying it will come to 5 to 6%, and finishing it will have around 5 to 6% of moisture. In water which are coming, which can send back to here, or we can decant it to the bleed stream. So if you see in short, the pulp is suspended, then we are forming the wet web, and then we are pressing to remove the water. Then it will go to the dryers, where it will be dried further, and then we can have the winding rolls and we can send them as a finished paper. So improvement in paper making. So increase in weight strength of paper products. The sizing of paper with die-hard starch and the use of newer types of resin and plastics such as polyethylene and particularly in kraft type paperboard is responsible for the increased use of paper in moisture condition. So here the weight strength of paper products, as we know the paper is the good absorption of moisture. So moisture will deteriorate the quality of the paper. So we have to add the material such that they will not allow the paper to absorb the moisture. So in avoid that one, we should add the water repellent. So generally the die-hard starch, then polyethylene, plastic, or the other material which are water repellent that are added. So the paper which is formed after adding this one will be moisture repellent. So the moisture absorption rate will be reduced if we add these fillers. Then modification machine. So incorporates a rubber belt before the pressing rolls, which can be varied in degree of elongation. And by changing to a list stage condition at the end of the operation, the fibers can be compressed and intertwined to improve strength. So here modification machine should be such that it can interlock the fibrous material. So interlocking of the fiber material will impart the high strength to the paper. Also the drying operation, the pressing, it may deteriorate the quality of paper. So we have to use the technique which can press it in equally, and we can get the good quality paper. Also the moisture content should be reduced at a very early stage in order to get it dried quickly, and we can roll them and we can send them for shipping. So as far as the economics is considered, so we have to study the 3 points. One is the shortage of raw material, then high prices and storage of chemicals, and the procurement of plant and equipment. So here the storage of raw material is considered. Then the raw material required for the pulping and paper is the baggage, then the wood pulps, the grasses, and the other fibrous and non-fibrous materials. So you have to send them for the storage. So storing is another problem because it will take the more space. Also they are the biodegradable, hence the attack by the bacteria is also on the raw material. So we have to take care of the raw material, and that raw material should be quickly converted into the pulp, and that can be processed into paper. So the storing and the prevention of the raw material from the degradation, they will affect the economics of the paper industry. Then high price and storage of the chemicals. So we require the more chemicals in order to digest the paper and for other things. So here the prices of these materials are very high. Also it will take in the storage of chemicals require the good quality material of construction. So these two things will affect the economics of the paper industry. Then procurement of plant and equipment. So as we have seen in India, the equipments are not so advanced. So in order to get the good quality paper, so we should have the good equipment. So the good equipment purchasing, it will have we have to invest the more amount of money. Also the plant require the good amount of space. So the plant, the location, and also the plant where you should establish, and the equipment which are procuring for the production of paper, that should be considered while studying the economics of the paper industry. Then there is cellulose material that you have to study. So cellulose is a polysaccharide used in chemical industries in the form known as chemical cellulose for the preparation of fibers and plastics. So in sugar industry we have seen the cellulose. So it was breaking down into the glucose molecules. So here the cellulose is a fibrous material which is required for the paper industry. So it is a polysaccharide, as we have seen earlier, used in the chemical industries and known as the chemical cellulose for the fibers and the plastic. So if you see the formula, it will be the chain of the C6H10O5. Then total glucose leakage will be 2x plus 2. Suppose this is the x, then the linkages we can find 2x plus 2. Then if you find the di molecule, then it will have the 6 linkages over here. Then the x for chemical cellulose, it will go around 250 to 1500. So here the x value or the number of the monomer units over here, they may vary from 250 to 1500. So here if you see, so it will have around 500 to 1300 glucoside linkages in the typical cellulose molecule. The density, it will vary from 1.55 to 1.58 grams per cc. Then solubility, it is insoluble in water and dilute acid and alkali, ordinary organic solvent, then soluble in cuprous ammonium hydroxide and the hydroxide and the carbon sulfide mixture. So the end users, they are the fibers called the rayon. So it is used for the manufacturing of the textiles. Then it involves the solution of the cuprous ammonia or the calcium sulfide caustic solution, then reprecipitate the cellulose in acidic solution while spinning filament. So first it is solubilizing, then we can precipitate, and while precipitating we will spin through the spinners and we can have the textile material. So this is the easier process of converting cellulose into the textile material. Then there are cellulose derivatives that we have to study. So first being the cellulose esters. So the inorganic and organic types. So inorganic will include nitrocellulose in lacquers, then films and in smokeless powders. Then organic, it is acetate, propionate, butyrate and solution of all these to form acids or aldehydes. Then cellulose ethers, it will contain the soluble in organic solvents like ethyl cellulose, benzyl cellulose, then soluble in water or aqueous sodium hydroxide. They will be methyl cellulose, sodium carboxymethyl cellulose or hydroxymethyl cellulose. Then if you see the lignin chemicals, so they are the two kinds, that is dimethyl sulfide, that is DMS, or dimethyl sulfoxide, that is DMSO. So they will be used as an odorant in natural and manufactured gas. Then preparing sulfur containing derivatives, so it is used as a solvent, and the chemical reaction that the lignin which is coming reacted with sulfur to give the dimethyl sulfides, and the dimethyl sulfide with N2O4 we can have the dimethyl sulfoxides, and then the NO with reaction with O2 can give back NO2O4, which you can use to convert the dimethyl sulfide into dimethyl sulfoxides. So this we'll see in the process flow diagram. So here we require the lignin. So lignin first will be with the reaction with sulfur converted into dimethyl sulfide, whereas the dimethyl sulfide with reaction with N2O4 we can give dimethyl sulfoxide, where N2O4 is required back. So here the black liquor which contains the lignin, it will come from the chemical recovery of the pulp mill industry, and the molten sulfur we are sending from the sulfur so that they will react over here. So it is a DMS reactor. It is operating around 230 degrees centigrade and 35 atmospheres. So here the DMS will be converted and they will send to the flash tank, where the material will be evaporated, the DMS will be evaporated, and the other non-lignic material or the dimethylated black litter to chemical recovery. So here the waste material or the lignin low content material, they will send for the chemical recovery in chemical plant, and here we will have the DMS which can go for the H2 separator where water will be removed. Then it will send to the methyl mercaptan scrubbers, where methyl mercaptan will be removed. So here mercaptan and the aqueous NH2 methyl mercaptan recovery or pulp mill. So here whatever the methyl mercaptan recovered, they will send here for the recovery, and NaOH solution 10% and 50% will be added. Then it will send to the dimethyl sulfide the column. So here the DMS will be formed and they will be stored as dimethyl sulfide product. Then heat is removed over here and the waste will be sent to the waste product. Then here DMS which is formed, we can convert them into the dimethyl sulfoxide by the reaction with N2O4. So when it will come for, it will go to the DMSO reactor, where it is maintained around 37 to 40 degrees centigrade, and N2O4 is added, and then it is caustic is sent to the pulp mill for the neutralizer, and then whatever the DMSO which is formed, it is evaporated and water will be coming out over here, and then sludge which is forming, which we can send for the disposal, and DMSO we can have in the DMSO column, where we can get dimethyl sulfoxide as a product. So if we, in short, if we see, then sulfur and DMS, they will come in the DMS reactor. The underflow they will send to the chemical recovery, whereas overflow they will send to the scrummer for the methyl mercaptan recovery. Then the DMSO column, then it may be dried and it will send to the DMS column. From DMS column, the dimethyl sulfide will get, we can send for the product, or we can send them for the dimethyl sulfoxide formation with N2O4. Then it is sent to the neutralizer and then followed by the evaporator, where we will get DMSO, and then after DMSO gas we can have the dimethyl sulfoxide product. Here problem is the optimization of yield of dimethyl sulfoxide. So here we have to see how to get the maximum yield of dimethyl sulfide, that DMS, from the lignin, as the liquor which contains the more chemicals in amount, so we have to go for this. Then material construction, so as they are the corrosive one, we have to use the stainless steel as the material construction. Then in the production of dimethyl sulfoxide, we are using N2O4 and the other chemicals. So they are explosive in nature. So you have to always take care of the while the oxidation step. So explosion hazards in the oxidation step always there, as we are using the N2O4. So these things you have to take care while we are forming the DMS and DMSO from the lignin. So we have to use the diagram for the further reference.